All right, we're going to simplify some rational expressions in this video. What that means we are going to do is first we factor everything. And then once everything's factored, we look and see what we might be able to cancel. So if we look at our first example, we see that we have two trinomials and we have to factor each one of those. Well, the first one, I'm going to write this off to the side over here. The first one is 2x squared plus 3x minus 2. You look for a GCF. This one does not have a GCF, so we're doing our guessing and checking. Because of that 2 in front, that means we have to guess and check this. So remember, your first terms have to multiply to 2x squared, so we'll try 2x and x. Your second terms have to multiply to a negative 2. So I'm going to use a 2 and a 1. One of them has to be positive, one negative, and as I think ahead down here, I know that these outside terms end up being multiplied. I'm going to put the 2 there, and I'm going to make it a positive 2. I'm going to make this one a negative 1. So now we check our inside and outside terms. That gives us a negative x. This is a 4x, and 4x plus a negative x equals this positive 3x. So that has been factored correctly. So I'm going to go ahead and write that over there. Of course, now I just lost it. There it is. So I'm going to rewrite this problem with everything factored. I have a 2x minus 1 and then an x plus 2 in my numerator. Now we have to factor our denominator. Again, if you look at it, no GCF, so we have to do our guessing and checking again. So off on the side, 2x squared minus 7x plus 3. Hopefully you guys have noticed you've gotten better at your guessing and checking. The more you do it, the easier it gets. So 2x times x gives us this 2x squared. I need two things to multiply together to give us a negative 3. But when you add your outside and inside terms, they have to add to a negative. So I'm going to make both of these factors negative, because a negative times a negative will equal a positive 3. All right, I'm going to go ahead and put the 3 out here so that when I multiply those, I get a negative 6x, which means I'm going to put the 1 right there. Remember, these terms multiply to 3. That gives me a negative 1x, and if you combine those, you get the negative 7. So we have factored this correctly. We're rewriting our problem over here, 2x minus 1, and then we had an x minus 3. All right, so here's our problem. We factored everything. Now that everything's factored, we get to cancel. So you only cancel things that are separated by that multiplication. If anything has an addition or subtraction sign connected to it, you cannot cancel it by itself. They're stuck together. So for example, this minus sign is connecting this 2x to this 1. I can't cancel a 2x with a 2x. I can only cancel a 2x minus 1 with a 2x minus 1. So that's what we can cancel. An x plus 2 on top and x minus 3 on the bottom. We cannot cancel anything there, even though it's tempting just to cross off those x's. Remember, this plus sign keeps the x and the 2 together. The minus keeps the x and the 3 together. So our final answer is x plus 2 over x minus 3. All right, so of course, if you have to guess and check, the problems might get a little longer, but you guys are getting better at that, so hopefully that will not take as long as it would have before. All right, so first I see a negative exponent. That's going to go on the bottom. So we're going to rewrite the problem. We have x to the 4th minus x squared over, that's a squared, x to the 4th minus 1 to the positive first power, so that's just going to be x to the 4th minus 1. All right, when we factor this, in the numerator, I can see we have x's in common. I'm going to take an x squared out. It leaves you with an x squared minus 1. Remember, if you factor out an entire term, you have to leave a 1 in its place. Over, now on the bottom, x to the 4th minus 1. Remember, our difference of squares pattern, did we square anything to get those two terms? Well, yeah, 1 squared is 1. And this one's a little tricky. X squared is x to the 4th. So this does factor into our difference of squares pattern, x squared plus 1, and then x squared minus 1. All right, well, I was about to say we can keep factoring this x squared minus 1 and this x squared minus 1. Those are both difference of squares pattern, but right now they're the same. So let's just go ahead and cross those off. X squared minus 1 over x squared minus 1. So on the top we have an x squared. On the bottom we have an x squared plus 1. And what we're looking for is to see if anything else cancels. You probably really want to cancel those x squareds, but remember this x squared has a plus next to it. Those are connected. So that means we cannot reduce this any further.